66 million years ago, a fireball brighter than 1,000 suns scorched across the sky, growing larger by the second. Animals scattered in terror, but there was no escaping what came next. In an instant, the asteroid slammed into the Yucatan Peninsula with the force of 10 billion nuclear bombs, vaporizing everything in its path. The Earth became unrecognizable. More than 50% of all animal species living at that time perished within just 24 hours, billions of creatures killed instantly by the fire, shock waves, and suffocating ash that now covered the planet. But the real horror was just beginning. In this grim new world, survival was a battle against impossible odds. The dinosaurs, once the undisputed rulers of the Earth, now faced a fight for their very existence. The mass extinction began with the giants. Among the first to fall were the great sauropods, like Brachiosaurus and Brontosaurus. Towering above the landscape, these gentle herbivores roamed in herds, stripping trees of their leaves and grazing endlessly in the lush forests and open plains. Their immense size and slow movement gave them little defense against the asteroid's aftermath. The impact debris blotted out the sun, plunging the world into a dark, freezing haze. Without sunlight, the plants they relied on began to wither and die. Within days, the air was filled with ash, and the land became barren. These giants, needing vast amounts of food to survive, began to collapse one by one. Hunger turned their once mighty herds into scattered, dying remnants. As their immense bodies fell to the ground, they became the first casualties of an ecosystem unraveling. The armored Ankylosaurus, known for its tank-like body and formidable tail club, also found itself unable to cope with the changing world. In life, it was a near-invincible creature, with its thick armor protecting it from the most fearsome predators, including Tyrannosaurus rex. It had thrived by foraging for low-lying plants, breaking apart tough vegetation with its beak-like mouth. But when the ground turned to ash and its food sources vanished, the Ankylosaurus was left wandering aimlessly. Its heavy body, once its greatest defense, became a burden. Exhaustion set in as it struggled to find food, and one by one, these armored titans succumbed to starvation. Even the fierce Triceratops was no match for the slow death that followed the asteroid's impact. These three-horned dinosaurs had long been symbols of strength, roaming in herds and using their massive frills and sharp horns to defend themselves against predators. Before the asteroid hit, they were a dominant force, grazing on ferns and plants in the warm, sunny plains. But as the skies darkened and the temperatures plummeted, the plants they relied on vanished. The Triceratops herd began to weaken. Their powerful horns were useless against starvation. Desperate and disoriented, they scattered in search of food, but the barren land offered none. Their mighty forms, once so full of life, eventually lay lifeless in the dust. The king of the dinosaurs, Tyrannosaurus rex, fared little better. Before the catastrophe, the T-Rex was an apex predator, stalking the plains and forests for prey, its thunderous roar echoing across the land. It thrived by hunting and scavenging, using its powerful jaws to crush bones and devour entire carcasses. But after the asteroid's impact, the rules of survival changed. At first, the T-Rex turned to scavenging the remains of fallen giants like Brachiosaurus and Triceratops. Battles between T-Rex individuals grew vicious, and competition for the dwindling supply of rotting flesh became a fight to the death. But even the mighty T-Rex could not survive in a world where food sources vanished completely. As the weeks turned to months, they too joined the ranks of the extinct. In the skies, the pterosaurs, including pterodactyls and the massive Quetzalcoatlus, faced their own battle for survival. These flying reptiles once ruled the air, soaring over vast landscapes and hunting fish, insects, and small prey. Before the asteroid, these skies were alive with their graceful flight. But the impact filled the atmosphere with ash and soot, making flight treacherous and reducing visibility to almost nothing. With their food sources disappearing and the ash-laden air choking their lungs, the pterosaurs began to fall from the sky. Their fragile bodies, built for flight, were ill-suited for a world where the very act of flying became a death sentence. Beneath the oceans, extinction unfolded just as brutally. Creatures like Mosasaurus and Plesiosaurus, the apex predators of the seas, faced a collapse of the marine food chain. Before the asteroid, the oceans were teeming with life. Plankton thrived under the sunlit surface, supporting fish and smaller marine reptiles, which in turn fed the larger predators. But the impact disrupted everything. Acid rain poured into the oceans, poisoning the water and killing plankton en masse. Without this foundation, the marine food web collapsed. The Mosasaurus, once a fearsome predator that could take down nearly any creature in the sea, found itself starving. The Plesiosaurus, known for its long neck and graceful swimming, was no longer able to find fish or squid to sustain it. Slowly, these majestic creatures succumbed, their bodies sinking to the dark ocean floor. Even smaller and more agile dinosaurs, like Velociraptor and Troodon, were not spared. Before the asteroid, these intelligent predators thrived by hunting in packs, using their sharp claws and quick reflexes to take down prey. They were adaptable, able to survive in a variety of environments, from forests to open plains. But in the aftermath of the impact, their prey disappeared, and their hunting grounds turned into desolate wastelands. At first, they scavenged for insects, small mammals, and even the remains of other dinosaurs. But as the months dragged on, even these scraps became scarce. The Velociraptor packs dissolved as individuals succumbed to hunger. The Troodon, with its sharp mind and keen senses, also faded away, unable to find a foothold in the new hostile world. But some creatures were still holding on, hidden in fractured forests and under rocky outcrops, clinging to the fragile thread of survival. Among them, Ornitholestes, a small, swift dinosaur with a body built for speed and agility, now weighed down by hunger and exhaustion, scoured the barren ground in search of food, desperate to find even a sliver of what it once thrived on. Around it, the earth was a graveyard of fallen giants, yet this one creature dared to persist. In the shadows of a collapsed forest, a family of Troodons huddled together. Their feathers now darkened with soot, providing just enough insulation against the frigid nights that had descended upon the land. The parents, once skilled hunters, were reduced to scavenging for scraps, tiny insects, rotting vegetation, or the remains of other creatures too weak to survive. Their young chirped softly, unaware of the precariousness of their situation, as their parents fought to keep them alive for one more day. Not far away, alone, a Sauronitholist scrambled over jagged rocks. Its keen eyesight, once used for hunting, was now focused on finding a safe place to rest. Its feet were blistered from the heat of volcanic ash, yet it moved forward, driven by a primal instinct to survive. This creature, like so many others, was living moment to moment, its future uncertain. These survivors, those few who managed to evade the initial destruction, owed their lives to chance. While the asteroid's impact brought destruction from the sky, fires raged on the ground, and only those hidden deep in caves, forests, or beneath the soil escaped the inferno. For some, it was their size. Smaller dinosaurs, such as feathered Troodons and the light-footed Sauronitholists, found shelter under bushes. Their bodies, insulated by feathers, offered a shield against the cold, helping them conserve body heat. The Maiasaura, known as the Good Mother lizard, faced a unique struggle. These dinosaurs had spent generations nurturing their young in carefully constructed nests. After the impact, some of these mothers led their hatchlings to higher ground, away from the flooding rivers and acid rain. They shielded their young with their own bodies, braving ashfall and poisonous air. Yet even their maternal instincts could not overcome the lack of food. Many Maiasaura perished alongside their offspring, a heartbreaking end for a species known for its care and resilience. Meanwhile, smaller herbivores like Hypsilophodon used their agility to find shelter in crevices and beneath rocky overhangs. These creatures, once abundant in forests, now relied on scavenging for roots or moss. Their speed kept them alive in the short term, but as the days turned into weeks, even the most resourceful of them began to succumb to hunger and exhaustion. Smaller carnivores like Compsognathus fared slightly better, feeding on insects or the scraps left behind by larger predators. But even then, they were not immune to the harsh realities of this new world. Competition was fierce, and every meal was a battle. In the end, the complete collapse of entire food chains meant that it was only a matter of time until the survivors would also succumb to the incredibly harsh conditions. For around 15 long years, the sun's light would not be able to penetrate the sun-blocking dust from the killer impact. As bleak as this cataclysm was, life would not be erased entirely from the planet. There were some creatures who did survive, and in fact, not all dinosaurs went extinct. Not only did some of these dinosaurs survive, they evolved into animals that are still around today. Small bird-like dinosaurs, particularly those closely related to modern birds, were among the survivors of this mass extinction. Species like Hesperornithides, a small feathered dinosaur, likely found refuge in dense vegetation or burrowed in sheltered areas, protecting themselves from the cold and chaos of the post-impact world. Their feathers, which may have originally evolved for temperature regulation or mating displays, became a crucial tool for surviving the freezing conditions of the impact winter. Another potential survivor was a nonce, a crow-sized dinosaur covered in primitive feathers. Before the asteroid struck, a nonce likely thrived by gliding between trees, hunting insects and small vertebrates. Its small size and arboreal habits may have allowed it to hide in dense forests and avoid the worst of the environmental collapse. As plants began to recover and ecosystems slowly regenerated, creatures like a nonce could adapt and find new niches, eventually giving rise to early avian species. Species such as Microraptor, another small feathered dinosaur, may also have had a better chance at survival. With its unique four-winged structure, Microraptor could glide between trees, giving it an edge in scavenging food from hard-to-reach places. Its small body size and adaptability to different food sources likely increased its chances of outliving its larger, ground-dwelling relatives. Then there was Archaeopteryx, often considered the bridge between dinosaurs and birds. Though it lived millions of years before the asteroid impact, its descendants and other similar feathered dinosaurs likely shared traits that proved vital for survival. Lightweight skeletons, quick reflexes, and the ability to forage in tight spaces gave them an advantage in a rapidly changing world. These survivors and others like them endured the ash-filled skies, freezing temperatures, and the starvation that wiped out so many other species. Over millions of years, they evolved into the birds we know today, carrying forward the legacy of the dinosaurs. From sparrows to hawks, every bird alive today is a testament to their ancestors' incredible ability to adapt and survive. The dinosaurs may have gone extinct 66 million years ago, but their legacy is far from over. In fact, their descendants are all around us, alive and thriving in the modern world. Birds, those familiar creatures we see every day, are the living lineage of the great theropod dinosaurs. Each one carries a piece of history in its feathers, bones, and behaviors. Take the cassowary, for example. This towering, flightless bird with its piercing eyes and dagger-like claws is as close as you'll get to a modern-day dinosaur. With one powerful kick, it can defend itself against threats or even kill a human. It's a fierce reminder of the theropods that once roamed the earth. And then there's the chicken. It may not look like much at first glance, but genetic studies have shown that chickens share surprising similarities with some of the most iconic dinosaurs, including Tyrannosaurus rex. The next time you hear a rooster crow, imagine it as a distant echo of the king of the dinosaurs. Ostriches, with their powerful legs and towering height, are another link to the prehistoric past. Their bipedal stride and speed hark back to their theropod ancestors, making them one of the most striking reminders of the dinosaur lineage. Emus, too, are part of this ancient family tree. These flightless birds, cousins of the cassowary, share the resilience and adaptability that helped their ancestors thrive for millions of years. Even ducks and geese, with their graceful movements and honking calls, trace their roots back to the age of dinosaurs. Their ancestors adapted to wetlands, surviving through the ages and evolving into the familiar species we see today. And then there are the raptors of the skies, hawks and eagles. These birds of prey channel the hunting prowess of their theropod forebears. Their sharp talons and keen vision are reminiscent of the skills that made dinosaurs such successful predators. From the fearsome cassowary to the humble chicken, every bird alive today tells the story of survival and evolution. But there was a time after the impact when strange and wonderful new animals would appear and take the place of the great beasts that seemingly ruled the earth. About 1 million years after the extinction of the dinosaurs, the earth was a very different place from what it is today. During this time, known as the Paleogene period, the continents were still in the process of moving and changing shape. The planet was much warmer than it is now, with tropical forests spreading across the globe, and the sea levels were much higher. The earlier Paleogene was characterized by the proliferation of mammals, birds, and reptiles, many of which were quite different from the species we see today. The ecosystems of the time were also different, with different food webs and interactions between species. As mammals evolved and adapted to the changing environments, they were able to exploit the planet's resources, which had once been dominated by dinosaurs. Within a few million years of the asteroid impact, the fossil record shows an explosion in mammalian diversity. There is abundant fossil evidence for the evolution of shrew-like mammals called Morganeucodonta, which eventually gave rise to the mammals we see today. Some of the earliest known fossils of mammals are from the Jurassic period, around 165 million years ago, and include small, insect-eating animals similar in size and shape to modern-day shrews. One of these is a 200-million-year-old species named Megazostrodon, which measured about 10 to 12 centimeters long. It most likely ate insects and small reptiles and was probably nocturnal because it had a larger brain, with enlarged areas likely dedicated to processing sounds and smells. This evolutionary trait was likely developed to avoid competition with reptiles or becoming prey to the dinosaurs. It might be hard to believe, but all living mammals today, including us, descend from this one line that survived. In the oceans, the first animals to appear after the dinosaurs were ammonites, which were relatives of the modern-day nautilus. They were important predators in the ocean and helped maintain balance in the marine ecosystem. In addition to mammals and ammonites, other early animals on Earth after the extinction of the dinosaurs included birds, reptiles, and fish. The early bird species were mostly small and similar in size to modern-day sparrows, while the reptiles of the time included turtles, lizards, and snakes. Fossil evidence shows that these early mammals changed in size and shape over time, as well as in their adaptations to specific habitats and food sources. For example, whales evolved from a terrestrial ancestor that lived around 50 to 52 million years ago and gradually became better adapted to life in the water until they became the fully aquatic whales we know today. This animal is named Pakicetus, a four-legged creature about the size of a goat that scientists now recognize as one of the first whales. Although it had the body of a land animal, its head had the distinctive long skull shape of a whale. Over time, these animals adapted to the water, losing their limbs, with their nostrils shifting backward and upwards, and their forelimbs turning into flippers. Of course, they grew immensely in size. Fossils of Pakicetus have been discovered in the Tethys Sea region, which was a shallow sea that existed between the ancient continents of Gondwana and Laurasia during the Eocene epoch. The oceans were home to a variety of marine animals, including many that are still present in the oceans today, such as dolphins, whales, sea lions, seals, sea turtles, and various types of fish. However, there were also many prehistoric marine animals that have since gone extinct. Megalodon, a giant prehistoric shark, is thought to have first appeared about 23 million years ago during the Miocene epoch. Megalodon was a top predator in the oceans, and it's estimated to have grown up to 18 meters in length, making it one of the largest known sharks to have ever existed. Some of the other prehistoric marine animals that were present in the oceans during the time Megalodon was swimming around were creatures such as Basilosaurus, which was a large prehistoric whale that could grow longer than 15 meters in length and lived during the Eocene epoch. It is one of the earliest known whales. There was another top predator in the oceans at that time, something even bigger than Megalodon, Leviathan, a prehistoric whale that lived around 8 to 12 million years ago during the Miocene epoch. This whale is estimated to have been about 13 meters long and had massive teeth, suggesting that it was a formidable predator. Leviathan is a close relative of modern sperm whales, but there were more than just these. Just sharks and whales in the seas and oceans. Dunkleosteus was a massive prehistoric fish that lived during the Devonian period and was known for its huge size, powerful jaws, and bony armor. The infamous Mosasaurus, that the Jurassic Park movies brought to life, was a type of marine reptile that lived during the late Cretaceous period. The largest fossil specimen measured a whopping 17 meters long. Mosasaurus had a long, streamlined body with 4 flippers and a powerful tail that allowed it to swim rapidly through water. Its skull was elongated and had numerous sharp pointed teeth, which it used to catch fish and other prey. But despite its size and fearsome appearance, Mosasaurus was not a dinosaur, but a type of lizard and is considered to be one of the largest and most successful marine reptiles to have ever lived. Then there was Archelon, a type of sea turtle that lived during the late Cretaceous period and was one of the largest known turtles to have ever existed. These are just a handful of the many creatures that evolved and adapted to aquatic life. But it was not just in the oceans that life diversified and exploded into many different species. There were many strange and bizarre-looking creatures that appeared on land as well. Creatures that lived on land, such as rodents, evolved from early shrew-like mammals and diversified into a variety of species, including mice, rats, squirrels, beavers, and many others. Carnivores also evolved from early shrew-like mammals and gave rise to cats, dogs, bears, and other predator species. Members of the cat family, Felidae, are believed to have evolved from a group of small, shrew-like mammals called myacids, which lived during the Paleocene epoch, approximately 66 to 56 million years ago. The myacids were a diverse group of carnivorous mammals that were adapted to hunting small prey. Modern-day mongooses can trace their origins to myacids. Over time, some miacid species evolved specialized features that made them more efficient hunters, such as retractable claws and more powerful jaws. One of these specialized miacids, called Prolocus, is considered to be one of the earliest known cat-like animals. Prolocus lived during the Oligocene epoch around 30 million years ago and had several features characteristic of modern cats, including retractable claws and a more powerful bite. Miacids evolved and diversified, eventually giving rise to various lineages of cats with different anatomical features, including the saber-toothed cats. One of the most well-known groups of saber-toothed cats is the Smilodon tribe, which included Smilodon and Hyaenodon. These cats were well known for their long, saber-like canine teeth, which were used for hunting and possibly for defense against predators. The earliest known members of the dog family, Canidae, are believed to have appeared during the Eocene epoch around 56 to 33.9 million years ago. One of the earliest known canids is a small, fox-like animal called Hesperion, which lived in what is now North America around 40 million years ago. Hesperion is believed to be the ancestor of all modern canids, including dogs, wolves, foxes, and coyotes. But there were other predators aside from the prehistoric cats and dogs roaming the plains. Terror birds, known as ferocirapsid birds, are a group of large flightless predatory birds that were native to the Americas approximately 2 million years after the extinction of the dinosaurs. The exact timing of the appearance of the terror birds is not well established, but it's believed to have been in the late Paleocene or early Eocene, about 62 to 58 million years ago. Titanes was one of the last and largest species of terror birds. These birds dominated the continent for millions of years before going extinct around 1.8 million years ago, possibly due to climate change and competition from other predators. Titanes was likely a carnivorous bird that fed on a variety of prey, which may have included other birds, mammals, reptiles, and possibly even large insects and invertebrates. Fossils of Titanes have been found in various locations in North and South America, and some of the bones show signs of carnivorous feeding, including tooth marks and damage caused by digestion. It's interesting to note that while some modern birds are descendants of dinosaurs, the terror birds are not. They are a separate and distinct group of birds that evolved independently from dinosaurs and belong to a group of flightless birds known as paleognaths, which also includes the modern ostrich, emu, kiwi, and the cassowary, which is the deadliest bird in the world. But terror birds weren't the only interesting and bizarre creatures to appear. Several species of prehistoric sloths evolved and lived during the Cenozoic era, which spans from about 66 million years ago to the present day. Ground sloths were the size of huge bears and lived from the Oligocene epoch to the Pleistocene epoch, which spanned from about 33.9 million years ago to 11,700 years ago. They were quadrupedal and had large claws that were likely used for defense and digging. Tree sloths lived from the Oligocene epoch to the present day. They were arboreal and had long limbs and curved claws that allowed them to move easily through the trees. Today, the only surviving species of tree sloths are the two-toed sloth and three-toed sloth. But where are the snakes, you might be asking? The evolutionary history of snakes is complex and not fully understood, but scientific evidence suggests that snakes evolved from a group of small lizard-like ancestors called stem squamates that lived more than 100 million years ago during the time of the dinosaurs. These early stem squamates were likely small insect-eating creatures that lived on the forest floor, much like the early shrew-like creatures. Over time, some of these stem squamates evolved, becoming more elongated and legless. The earliest known fossils of snakes, such as Aristorhynchus, date back to around 95 million years ago and show features that are similar to those of modern snakes, such as the presence of a flexible skull and a long, slender body. Titanoboa would evolve from a small group of boas and is considered to be the largest snake ever discovered, with the largest known specimens estimated to have reached lengths of up to 12.8 meters long and weighed up to 1,135 kilograms. So, while snakes did not evolve directly from tiny shrew-like creatures, they did evolve from small lizard-like ancestors during the time of the dinosaurs and have since evolved to become the diverse group of animals that we know today. Finally, we come to our own ancestors. Fossil evidence shows that early primates had small bodies, long tails, and grasping hands and feet, adaptations that would have been useful for climbing and foraging for food in trees. Over time, primates evolved into the diverse groups of primates that we have today, including monkeys, apes, and humans. But there's so much more to cover about our own species, and we'd need more time. So, if you want to see that in another video, let us know in the comments. If you enjoyed the video, show us some support with a like. We appreciate it, and make sure to subscribe to stay tuned here for more videos in the series. Thanks for watching.